This is Bob Capetta from the College of the Florida Keys, and this lesson is on solving rational equations. So we have the equation 2 over x plus 1 over 2 equals 5 over x. We want to solve for x. We're going to solve it in a very similar way to adding rational expressions. I like to work vertically, so 2 over x plus 1 over 2 plus 5 over x. We have to build a common denominator. The factors we see an x and we see a 2. The most x's in any one place is 1. The most 2's in any one place is 1. So my common denominator is 2x. Now what's new? From here to here a 2 is new, so I'm going to circle a 2 and put it upstairs. From here to here an x is new, I'm going to circle an x and put it upstairs. From here to here a 2 is new, I'm going to circle it upstairs. So there's the stuff that was up before. Here's all the circled stuff. We're going to go ahead and put it up. So 2 over 2 would reduce to 2 over x, as we see. X over x reduces to 1/2. 2 over 2 reduces to 5 over x. Now we have 2 times 2 is 4 over 2x. 1 times x is 1x over 2x. 5 times 2 is 10 over 2x. So we've identified a common denominator for all these. So what we have is 4 over 2x plus 1x over 2x equals 10 over 2x. And we have a common denominator on the left side, so we can write this as 4 plus x all over 2x equals 10 over 2x. If that's the case, the fractions equal and the bottoms equal, therefore the tops have to equal. 4 plus x has to be 10, and x is 6. But we're not quite done yet. We always have to check the domain. Looking at our original problem, 2 over x plus 1 over 2 equals 5 over x. X could not have been 0. Is it 0? It is not. It's 6. So 6 is an acceptable answer. You must go back and check your original question to see if your answer shows up in the domain. All right, my next question is x squared over x minus 3 equals 9 over x minus 3, a rational equation. The two denominators are equal. The two fractions are equal. Therefore, the numerators, the tops, have to be equal. So x squared has to equal 9. We'll subtract 9 from both sides. X squared minus 9 will be 0. And then we factor that to get x minus 3 times x plus 3 is 0. Which tells me then that x minus 3 is 0 or x plus 3 is 0. Solving that, we get x equals 3 or x equals negative 3. But again, at this point we have to check the domain. Make sure our answers are acceptable. Is 3 acceptable? And the answer is no. 3 is not in the domain. If I use 3, I get 3 minus 3 is 0 downstairs. X cannot equal 3. 3 is not in the domain of the problem. Therefore, my only answer to this question is negative 3. So again, check the domain. Make sure that your answer is allowable. Make sure your answer does not give you a division by 0 situation. Next up, we have 1 over x plus 1 plus 1 over x plus 1 equals 2 over x squared minus 1. I like to work vertically. Let's factor. X squared minus 1 is x minus 1, x plus 1. We want to build a common denominator. I see x minus 1's and I see x plus 1's. The most x minus 1's in any one place is 1. The most x plus 1's in any one place is 1. Therefore, my common denominator is going to be x minus 1, x plus 1. X minus 1, x plus 1. 1, 1, 2 are brought over, then look for what's new. X minus 1 was there before, so x plus 1 is new on the bottom. Put an x plus 1 on the top. X plus 1 was on the bottom before. X minus 1 is new. Put an x minus 1 on top. Nothing is new on the third fraction, so nothing has to change. Multiplying this, we get x plus 1. Multiplying this, we get x minus 1 over our common denominators. So now what do we have? This fraction plus this fraction equals that fraction. These guys have a common denominator, so we could say x plus 1 plus x minus 1 all over x minus 1, x plus 1 equals 2 over x minus 1, x plus 1. At this point, we have two fractions that are equal. If two fractions that are equal and the bottoms are equal, the tops have to be equal. So x plus 1 plus x minus 1 has to equal 2. So that tells me what? 2x over all this stuff has to equal 2 over all this stuff. 2x has to equal 2. And my answer is x equals 1. Am I finished? Nope. As always, we have to check the domain. Is 1 allowable in this problem? And I can see right here it's not. If I put 1 into this fraction, I get 1 minus 1 times 1 plus 1. That gives me 0. If I go all the way back to the original question, was 1 in the domain? No. 1 makes this fraction 0. 1 makes that fraction in the denominator 0, and that is not acceptable. So after checking the domain, what do we find? 1 is not allowable as a solution, so therefore there is no solution. And the symbol that we use for that is that circle with a line through it. That's our preferred symbol. Okay, let's do another one. Here we have 3 over 2x plus 3 minus 1 over 2x minus 3 equals 4 over x squared minus 9. Again, I prefer to work vertically. We're going to build common denominators. Need to factor 4x squared minus 9. That's 2x minus 3, 2x plus 3. Now I need to build a common denominator. I see a 2x plus 3. I see a 2x minus 3. Those are the only denominators that I'm seeing. So my common denominator will be 2x minus 3, 2x plus 3. I'll bring over the 3, 1, and the 4. But then I need to see what's new. 2x plus 3 was there before, so 2x minus 3 is new here. 2x minus 3 was there before, so 2x plus 3 is new here. Nothing is new on the third one. Again, notice 3, 1, and 4 are brought over. 2x minus 3 new here, so 2x minus 3 up and down to keep an equivalent fraction. Notice if it would reduce, I'm back here to 3 over 2x plus 3. 2x minus 3 was there before. 2x plus 3 multiplied on the bottom, to be fair, multiplied on the top to keep an equivalent fraction. And then the bottom, nothing has to change. Distributing, we get 3 times 2x is 6x, minus 3 times 3 is 9. 1 times 2x plus 3 is, of course, 2x plus 3. So now I get this fraction minus this fraction equals this fraction. This fraction minus this fraction, they have a common denominator, so I can write it as a single fraction and say 6x minus 9 minus 2x plus 3 over all this equals 4 over all that. And if the fraction's equal and if the bottom's equal, then the tops have to equal. So 6x minus 9 minus quantity 2x plus 3 has to be 4. And make sure you use parentheses to distribute the minus sign properly. So 6x minus 2x is 4x, negative 9 minus 3, negative 12. 4x minus 12 is 14. Add 4 to both sides. 4x is 16. Divide by 4. And we get x is 4, but we're not finished. As always, we need to check the domain. So I want to go back to the original question and see, is 4 allowed in the original question? So we go back here. 2 times 4 is 8. 8 plus 3 is 11. That's fine. 2 times 4 is 8. 8 minus 3 is 5. That's fine. 4 squared is 16 times 4 is 64 minus 9. That's fine. No division by 0 things anywhere. So after we check the domain, our answer of x equals 4 never makes the bottom 0. Therefore, we can conclude that our answer is 4. 4 is the solution to that original question. All right, take a look at another one. We have x over 2x minus 6 minus 3 over x squared minus 6x plus 9 equals x minus 2 over 3x minus 9. I want to work vertically, so I do. And then we need to factor. 2x minus 6 is 2 times x minus 3. 3x minus 9 is 3 times x minus 3. X squared minus 6x plus 9 is x minus 3 times x minus 3. So here's our factored version. The next thing we have to do is build a common denominator. I need a 2, I need a 3, and I need some x minus 3's. But the most x minus 3's I see in any one place is 2 of them. So my common denominator needs a 2 and a 3, x minus 3, x minus 3. So that's our common denominator. We're going to bring over our numerators of x3 and x minus 2 and then look to see what's new. So you'll notice the x I brought over, the 3 I brought over, the x minus 2 I brought over. 2 and x minus 3 were there before, so 3 is new. Downstairs, bring it upstairs. X minus 3 is new downstairs, bring it upstairs. In this situation, 2 and 3 were new, so 2 and 3 are new downstairs, put 2 and 3 upstairs as well. In this situation, 3 and x minus 3 were there before, so 2 is new downstairs, put it upstairs. X minus 3 is new downstairs, put it upstairs. So we have a lot of simplification to do. The easiest one, of course, is the middle. 3 times 2 is 6 times 3 is 18. 18 over all this. Up here we have 3 times x minus 3, which will give me 3x squared minus 9x. On the bottom, I multiplied x minus 2 times x minus 3 first. X squared minus 2x minus 3x minus 5x plus 6 times 2. And this is what we have. We have common denominators. Notice I wrote 2 times 3 is 6, and I wrote x minus 3 times x minus 3 is x minus 3 squared, just to make it a little easier. So now I have the common denominator. I am ready to try to solve the equation. This fraction minus this fraction equals this fraction, which is what we have. We have a common denominator here, so we can write a single fraction and say 3x squared minus 9x minus 18. Normally I would say put this in parentheses, be careful with subtraction, but it's a monomial, so it's not really crucial. So we can write it this way. 3x squared minus 9x minus 18 over 6 times x minus 3 squared equals 2x squared minus 10x plus 12 over 6 times x minus 3 squared. The two fractions are equal. The two bottoms are equal. Therefore, the two tops have to be equal. Now we've got to solve this quadratic equation with factoring. We will subtract 2x squared from each side. 3x squared minus 2x squared is 1x squared. We'll add 10x to both sides. Negative 9x plus 10x is plus x. We'll subtract 12 from both sides. Negative 18 minus 12 is negative 30. So we get x squared plus x minus 30 is 0. Factoring that, we will get x plus 6 times x minus 5 is 0. Therefore, x plus 6 is 0 or x minus 5 is 0. Solving that, x equals negative 6 or x equals 5. But we don't just finish. We, of course, have to check the domain. So we're going to go back to our original question and see what numbers were not allowed. What numbers would give us a 0 in the denominator? So this was our original question. 2x minus 6 is 0 when x is 3. 3x minus 9 is 0 when x is 3. X squared minus 6x plus 9 is x minus 3 times x minus 3 is 0 when x is 3. So all of these would be 0 when x is 3. 3 cannot be our solution. Well, what did I say? What do I have? I have x equals negative 6 and x equals 5. Neither of those are 3. Therefore, they are both acceptable as solutions. And my final solution to this problem is the set of numbers containing negative 6 and 5. And that will conclude this lesson.